Hello ladies and gentlemen, welcome back. Hey look, this video tutorial is for students who are in Geometry Goal 1, and you'll notice, wow, there's a lot fewer topics on the screen. That means we are finally in the end game. No pun intended. What we're going to be doing now is dealing with a couple of DSA questions, rounding off our tutorial, and getting used to the biggest, most important, most influential part of geometry, and that is deductive reasoning and proofs, which is also low-key some of Ms. Dubois' favorite things to do, with the exception of one topic, which we'll get to in a second. So first thing is first, we have to do some definitions here. If you have, and I know my IST kids, when you start learning your programming, this is going to look very familiar. If you've ever seen this sentence before, if something, then something, that is called a conditional statement. So I'm going to say, what's the most broad generic thing I can say? We're going to say if P, then Q, okay? What we're going to do is there's a couple of things that we can do with this, and they don't give you the actual names of this, which is too bad, but your if part is going to be called your hypothesis, and then your Q, the thing that comes after the word then, is going to be your conclusion, and that sounds suspiciously like a science phrase. Mr. Milliken would be proud. Conclusion, there we go. All right, from here, oh no, the lag. From here, there are a few things that we can tell about the truth of these statements, okay? So first things first, they're going to ask you a couple of things for these topics. We'll go through it one at a time. First things first, consider the following statement. Keith is wearing tennis shoes. Check all the statements below that are the negation of this statement. So here's a new word for you, again, because geometry is vocab heavy. Negation. Like that thing will keep up. That means you're including the word not. So you are including the word not. There we go. So for example, it is not the case that Keith is wearing high heels. High heels is not the sentence because we have tennis shoes over here. So Keith is not wearing tennis shoes. Keith is wearing high heels. That's not what it's talking about. Now, next up, if the sign is on the table, then the store is closed. Conclusion. Conclusion is your then piece. So then the store is closed. Where is the store is closed? Right here. Next up, I am in geometry class. We want the negation, which means we're inserting the word not into our sentence. So I am not in geometry class. That makes sense. I am in physics. No, that's not it. It is not the case that I am in geometry class. Now notice, you don't usually see this in the software. These are checkboxes. They're not bulleted points that you tick off. So that means you can check more than one in this topic. Next up, if the team is practicing, then the team has won its most recent game. What is the hypothesis? Team is practicing. So where does it say team is practicing? Right there. And that's how this particular topic is going to be done. There's actually a lot more to do with if P than Q, but before we get there, I have to talk about my least favorite topic, counterexamples. So what is a counterexample? A counterexample is something that proves a statement false. Now we just wait for our mouse to catch up. False. There we go. So for example, if they are, and this is a DSA question, just to make life even more fun for you, for my least favorite topic in the chapter, if the length of XZ is 52, so we have a segment, and we know that the length is 52, and then we're told this is XZ, and then Y is somewhere here. They're telling you that the only option for Y to exist is if one of them is 40 and one of them is 12. Well, I mean, there are a billion other options we can do. We can do 41 and 11. We can do like 1 and 51. You know, there's a bunch of counterexamples we could offer. Next up, if your 1 and 2 are supplementary, then they must be obtuse. So this is our vocab words from before. Supplementary means they add up to 180, which means it's a straight line. Then one of them must be obtuse. Gee, I wonder if there's a possible angle you can come up with where both of them are not obtuse. And the obvious conclusion is going to be 90, and 90 is our counterexample. If the measures of all of these angles add up to 180, then all of them must be acute. In other words, all of them must be less than 90. Well, gee, there's a good example of a counterexample. That's 3 angles that add up to 180, and one of them is very obviously an obtuse angle. So let's say 100, 10, and 70. Eeny, meeny, miny, mo. Those all add up to 180, and one of them is over 90. Then the perimeter of a rectangle is 28. Then the length is 7, and the width is 7. That's what they're telling you. Well, what other additions can get you up to 28? So let's say you have a length of 1 and then a length of 13. That will still give you a perimeter of 28, and that's what counterexamples do. For students, and I remember when I was in high school, this was the hardest thing for me to do, to figure out what's the thing that makes it false. It is legitimately challenging for people who are new to this, which is basically every geometry student ever. So take that with a grain of caution. So if you have over here 2 complementary angles, which means they add up to 90, then one of them must have a measure that's less than 45. Well, no, what if they're both 45? 45 and 45 adds up to 90. Let's see here. What if you have 180 degrees worth of angles, but one of them has to be obtuse? Well, let's pick one where all of them are acute. So 60, 60, 60, which is the exact opposite of the one we were doing here. Let's see here. We have an angle measure, WXZ. So WXZ of 50 degrees. And then Y is in the interior. So the only option is 25 and 25. Well, gosh, that's really hard. What's the most extreme counterexample I can think of? What about 1 and 49? How about that? Next one, they're going to give it to you again, another perimeter one. The perimeter is 32. That means 13 and 3 are the only options. And the question is that actually the case? No. We can come up with any bunch of numbers we want for counterexamples. Moving on from there, now we're going to get into deductive statements and conditional statements. And we're back to the if P, then Q. If P, then Q. I had written that before. If you have an if P, then Q, you want to keep an eye out for what statements are true and false. So what you're going to be doing here, if P, then Q, computer. If you have an if P, then Q, what you're going to be looking for, they're going to give it to you in 3 options. First, they're going to ask what else is true. So you're going to have not Q and not P. What that means is you are flipping both your P and your Q, and you're inverting it, meaning you're inserting the word not. Next, if they tell you if P, then Q, and then the very next sentence is P, what answer are you looking for? This is the law of detachment. You're going to look for Q in your dropdown. All right, so the last thing is going to be, it's going to be like this, is it, computer? Last thing is the longest one they give you. They say if P, then Q, and then they give you an entire second sentence. If Q, then, what's a letter? R. What they're going to do there, that's syllogism, and I love that word syllogism, and I never get the chance to use it in common parlance. But what you're doing effectively is cutting the middleman. So all of Q, being that middle man, is going to be removed. And you're left with if P, then R. Those are going to be the things that you are looking for in order to give your statements. So if the play is a success, then Carmen likes milk. What statement is true? We're only told if P, then Q. So if Carmen does not like milk, then the play is not a success, and I did not give myself enough space to write that. Next up, dress is on sale, geometry is the fave. If geometry is the fave, then television is broken. So that's the biggest one. That's the really long sentence. So I'm looking for P, then R. What's my P? Dress is on sale. What's my R? TV is broken. That's what I'm looking for in my drop-down menu. Next, Salma heard the radio. I'm in my first period. Salma heard the radio. So what's the first thing? That's going to be the Q. I am in my first period class. Excuse me. Next one, river is overflowing, Susan's favorite joke. Okay, then they're told river is overflowing. So P got repeated twice. That means that's the middle one. What's our answer? Q, which is Susan's favorite joke. If the dress is on sale, geometry is the favorite. If geometry is the favorite, the TV is broken. So again, this is the long one. We're cutting the middleman, so we are looking in our drop-down for dress is on sale, TV is broken. If Bill is a doctor, then the mouse escaped the cat. So it's only the one sentence. That's the smallest one of the bunch, which means it's this one. So we're looking to flip and then not. So if the mouse has not escaped, then Bill is not the doctor. That's what you're going to be doing for truth statements. And then, at last, la pièce de résistance. Oh, isn't it beautiful? Proofs. Ms. Dubois' favorite as I rub my hands in glee. All right, so proofs is the biggest thing for people who are in geometry. It is also probably for a lot of students the hardest thing. I remember how much I was banging my head against the keyboard when I was in high school. Like Ms. Dubois, the trained math teacher, did not get proofs until she was in college. So, degree of respect here. What I can do to help you, because these are not the pencil paper days where I could sort of subconsciously get you guys ready for it beforehand, is what you want to do is you want to pick the things that are justifying statements, okay? Which they are nice for you in Goal 1, and they do it to you in later chapters too. Do your justifying statements first. So what you're doing is you're trying to figure out, well, what is each of these lines of this proof actually telling me? So for example, we are told that D, E, F, D, E, F, D, E, F. And look, I'm labeling my diagram. I've said this for several videos now. Label everything. DEF is the sum of the measure of angle 1 and angle 2. Two small angles add up to a big. What is that? That is segment addition. And when you look in your drop-down, somewhere there's going to say the phrase segment addition. Okay, so far so good. Next up, what are we told? HGF. HGF, which is that one, is going to be add up of these. So we have segment addition again, okay? My terrible handwriting. DEF and HGF. DEF. So this angle is congruent to this angle, HGF. All right, so far so good. Now I don't immediately know why that's true until you realize that sometimes they actually hand you something on a silver platter. And so what we would do is we would actually write given. And in point of fact, if they give you statements like they do over here and they do over here, look for them in your proof first, find them, pull out your drop down, use the word given. So if I have the measure of angle 1 equals the measure of 3, is that here somewhere? Measure of angle 1, there it is. So I know automatically that is going to be given. Okay? Next up, let's see here. 1 plus 2 equals 3 plus 4. 1 plus 2 and 3 plus 4. Since these things are equal, we replaced them with what they're equal to. What's that called? That is substitution. Substitution. I'm going to put a little asterisk there because some kids, when they're first getting used to this, have trouble seeing the substitution. And we're actually going to be using substitution again in a second. So be wary of that. Look for that and keep an eye out for it. Make a note in your notes that substitution is hard to see so that you know what to look for. Then what happens? Hey, look, we went from angle 1 and we switched it to angle 3. What is that when you replace something with something else? Oh, wait, we were just talking about it. That is substitution. All right? And then what did we do from here to here? What changed? We have 2, we have 4, we have 3, we have 3, we have... Oh, the 3's completely disappeared. Well, what do you do when you disappear? You used subtraction, and somewhere in your drop-down you're going to see the phrase subtraction. It's probably subtraction property of equality. All right, so far so good. This is going to take some practice, but it's worth investing the time. Next up, we have a given. Let's see here. There it is. Given. And then 1 equals 3. Given. So I found the easy stuff. Next up, QPS. QPS is this. So that's segment addition because 2 small angles add up to a bigger angle. So segment addition. I'm going to start shorthanding this. VPT. VPT is 3 and 4. That is also segment addition. You guys will have to tell me in the comments whether or not you have segment addition for all of the permutations of this topic. Let me know. So then I sort of know from over here, if we know that those two are equal, and then we have our segment addition, so do we replace it? So that's 1 plus 2, and that's 3 plus 4. Yep. So this is substitution. All right. And then we did substitution again. Substitution. Because the 1 got replaced with a 3. And then we got rid of things. So we did subtraction again. Subtraction. So I didn't do a good job of getting screen grabs in the sense that this ended up being the same number of answers for both of these. So let me know if there are other permutations. Give me a screen grab, and I don't mind making a one-off video for it. But this topic right here, let's see here, this is a DSA question. This unlocks a whole bunch of topics in later chapters. Let's see here, this is a DSA question, and conditional statements are also DSA questions. So it's a pretty heavy family of topics to take care of. But that's everything I've got for now. As always, stay happy, stay healthy, stay safe. I'll see you in the next video.